Okay, right. So this topic is new, right? I think you probably have not done this yet. Haven't started, in school? The chemical changes.
Teacher just started only.
Oh, just started only. Okay. All right. There should be some experiment. Okay, let me see. Snehan never do her work also. Okay. All right. We have one question from last lesson, right? Do you remember?
Yes.
Okay, so very quickly, let's just go straight into the questions. You see? So this is the one. Okay, so name the process of heat transfer that occurs at the bottom of the pan. You know what process is that?
Conduction.
Conduction, because it's direct heating, right? So it's direct heating. It's just like taking like a metal rod and then putting it into the fire. Okay, so it's actually transferred. Okay, heat is actually transferred by conduction. Okay, then you see there's rice at the bottom of this pan, right? So of course, this this aluminum pan gets heated first. And when it is hot, it will actually pass on the heat to the rice because rice is directly in contact with the bottom part of the inner side of the pan. So therefore, the heat will also be passed on to the rice by conduction. Okay, so if you were to be asked this kind of question, what is happening, as in what is happening throughout the entire process of cooking the rice, then you have to slowly explain. So firstly, the aluminum pan here gets the heat, okay, by conduction, right? Because the heat is applied to the pan. Then the pan gets heated. Okay, it has a lot of heat energy because the rice is directly in contact with the pan. Therefore, heat is transferred to the rice from the pan via conduction also. This part you can understand, right? So of course, the water here, okay, the water here will also get the heat energy from the rice because you will be able to see that there are water in contact with the rice, right? So they gain the heat also by conduction. But the moment they gain the heat, they start moving. Because they are hotter already, right? They are hotter. In that sense, they have more kinetic energy. They move faster. They expand. So they are going to rise up. Okay, so this is the convection current this way. All right. Okay, so I'm explaining a little bit more than required. Okay, but in part C, you will need to know this. So we go to part B first. Why is the handle made of plastic? Why do you think the handle is made of plastic?
The bad conductor of heat.
Yeah, it's a poor conductor of heat. But you're not answering the question there. They say,
So it conducts the heat away from the user's hand, so the user will be burned by it.
Okay, you say that it's a poor conductor of heat. That is good. Okay, so it doesn't get hot, right? Plastic hand.
It doesn't get hot. So when there's a user using this the pan, then they won't be burned by it.
Yeah, correct. That is the complete answer. If you're just saying it's a poor conductor of heat, it's not complete. Yeah, it's not complete because you didn't fully answer the question. A lot of students make this error, not just you. Yeah, so you have to complete it by saying, okay, Plastic is a poor conductor of heat. Try not to use the word good or bad. It's not good and bad, it's good and poor. Huh? Good and poor conductor of heat. Don't use bad. So, okay, the plastic handle will not get hot, and the user, okay, of the pen will not get burnt. Yeah. Okay, so now you have to talk about how the water at the top of the pan gets hot. Remember just now I actually described to you, right? Huh? Yeah. So you have to give a very complete answer, you have to say that the aluminum pan, which is hot, okay, transfer the heat to the rice via conduction. Okay, then after that, you're going to say that the water, okay, that is at the bottom of the pan will get the heat from the rice also via conduction. Then say that this water that is heated, okay, that is hot now, it will actually, Sneha is here, it will actually start to rise up because it's less dense, okay, and then the cooler water will come down to take its place, something like that. Okay, so let's try to answer this. Okay, I write down for you, huh? Okay, both of you.
Do we need to say it's like they gain heat through conduction?
Yeah, you have to write down conduction first. The rice gains heat from the pan via conduction. Water at the bottom also gains heat from the rice via conduction. Yeah. You know why via conduction? Not because the water is in contact with the rice here. That's how they transfer. Okay. That's why the water at the top, okay, which is not in contact with the hot rice, doesn't get the heat, ma. Yeah, lor. So it's happening this way. Hi, Sneha. Hello, Sneha. Can you turn on the camera? How are you, Sneha?
Okay.
You must be busy, right?
Yes.
Okay, so I am actually going through this with Zenith. All right. The heat is then transferred to okay, my answer is long because mine is a very complete one. So because of the rising and then the coming down, right, of the hot and cold water, okay, sets up this convection current and allow the heating of the water. Actually, it's not just the top of the water that gets hotter, it will actually be throughout. Because convection current goes round all the time, okay? Convection current is thus set up okay, so we talk about the water throughout. Sneha, do you remember you asked a question before about the assessment? Okay. And then you were wondering what is the actual answer? You still remember that part? Do you manage to find out? Let me just check.
Like my W1.
Yeah, I think so.
Was like a 2-mark question, right? So 1 mark was for the stating the like more like chemical, like more potential energy will be like converted to kinetic energy. That's like one part, and the other one was it had with like more force or something.
To do with force, right?
Yeah.
Yeah, okay. So I actually did look
We
up.
have to mention, so.
Yeah. I actually did look up on this, and then I have a very, very long answer. Later I share in the chat, okay? So it's like about leaning back before throwing a ball. This person will be able to increase the distance between the body and the release point, okay? Thus engaging more muscle, which then will generate more power and speed, something like that, okay? There are more to it. There are many ways to answer this question, in fact. Yeah. I cannot let go of this question, because you asked me about it. Then I keep thinking, I know it's about force and I know it's about the potential energy, being converted to more kinetic energy, but I actually wanted to find out, in greater detail. Okay, so later I sent to both of you. Zenny, if you take a look also. Very interesting question. The school actually asked in the WA1. Okay. So have you got down this answer?
Okay. Instead of saying to take its place, can you say like displace it?
Where? Here?
Hot water displaces cold water.
Hot water displaces cold water. You see, when the hot water goes up, right? Okay, because when it goes up, something else must come in to take the place here. It cannot be vacant here. Cannot be empty also. So when this goes up, it is also helping to push down the colder water. Yeah, but being hot and cold already, okay, will cause them to have different density. So one will float upwards, the other one will come down. Yeah, it's just a matter of where they will be coming down. So this current is set up in this manner because the heat is more centralized to the center. Okay. But if let's say the heat is right at the corner here, then of course the current will be different. Right? You get what I mean? If I actually put the heat here, I erase this part. I show you what I mean. So if my heat is actually just here, okay? So only the water here gets heated up, right? And then it rises. So the current now goes in only one direction. When you're heating in the center, the current goes 2 directions. You notice that? Yeah. So when it's right at the corner here, okay, then it will be this particular direction. Just like the chimney experiment. Okay, Zenith? Okay, but then if let's say the heat is throughout, then there's a lot of convection current going on. Not just 2 directions like this or 1 direction. There'll be many mini ones.